Dear friends, welcome to STEM Scholar. See, today we are discussing one of the most spectacular things on the sky. It is seen that sometimes we can see beautiful colors, beautiful display of colors on the sky. This beautiful display of colors is nothing but rainbows. Today let us discuss about rainbows. Rainbow formation. Rainbows. See, first of all, what is a major condition for obtaining a rainbow? As told in the introduction, it is one of the most spectacular observation on the sky. Somebody may be dancing once we are seeing the rainbow. Somebody may be in a happy mood if you are seeing the rainbow. So it's a wonderful thing, it's a wonderful experience. And how it is obtained on sky, how it is formed on the sky, and what are the conditions to obtain the rainbow on the sky. See, the conditions are, the sun should be, suppose sun should be at the western horizon, west. Sun should be west, at the west, and it should rain. Rain should be there, and we are standing here. A person is standing here with his back towards the western horizon. Then here rainbow is obtained. Rainbow is obtained on eastern horizon. So this is the first condition. So first, the sun is in the western part of the sky and it's raining, and an observer is there. Observer is standing with his back towards the western horizon, towards the western part of the sky. Then rainbow is formed on the eastern part of the sky. So to obtain rainbow, and or another situation, suppose sun is at the eastern part, sun is east, it's raining, and the observer is here. This is west. The observer is standing with his back towards east. Sun is the east, so observer is standing with his back towards the east. If he is standing with his back towards the east, he will obtain rainbow at the west. Rainbow at the west, western skies. So the condition is sun should be opposite. Sun and observer's sky should be opposite. This is the condition for obtaining the rainbow. So what are the major things that are occurring once we are obtaining the rainbow? Surely we will be obtaining colors. So usually a dispersion will occur, and there will be refraction. And for surely and not for the least, refraction. Refraction is also occurring. So dispersion is occurring, refraction is occurring, reflection is occurring. Let us think. Let's take the case of a single raindrop. Usually rainbows are obtained after the sunlight is hit on the raindrops, water drops. Sunrays are passing through the water drops. Once sunrays are passing through light rays passing through the water drop, it is passing through the water drop. So usually refraction will occur. Light is coming from rarer medium. This is air, this is water, So light rays entering from air to water. So usually refraction will occur. And what are the other things? See, interesting. Let's take the case. A water drop. A ray is falling. A ray is falling on the raindrop. So it is coming from rarer medium to denser medium. This is air. From air to water it is entering. So refraction will occur. Change in the path will occur. And also there will be dispersion. Also there will be dispersion. And once it here, the condition for total internal reflection is satisfied. And instead of going outside of the water drop, it gets internally reflected. So it is internally reflected. It is internally reflected. It is internally reflected. So here we are obtaining violet, here you are obtaining red. So there is a difference. There is a difference in angles between them. Here 42, here 40. So these are the things that are occurring in a raindrop. First of all, the raindrop is falling on the sun rays are falling, the rays falling on a water drop. Once the ray is falling on a water drop, it gets refracted. With the refraction, one more phenomena is also happening. What is that one more phenomena? That is dispersion. The white light is separated into 7 colors. So 7 colors are obtaining: refraction, dispersion. Then here, total internal reflection is occurring. Internal reflection is occurring, and the rays are coming out. Once it reach here, again refractions are occurring. So one refraction here, one refraction, one reflection, and again one refraction. So two refractions, and one total internal reflection or internal reflection, and one dispersion. This is a major thing that is needed to occur in the case of rainbow. Let us take one situation. 2 water drops. Rays are falling on it. Rays are falling on it. It is coming from air to water. So refraction will occur. Refraction will occur. And also here, dispersion is automatically occurring. And also here, total internal reflection is occurring. And the rays are coming out. The rays are coming out. So here, one ray we are obtaining. Here, other ray. So what is happening? This is violet color and this is red color. Both are reaching observer. Both are reaching the observer. Okay. Instead of reaching both, a situation is there. Here we are seeing here. This is the observer where it is placed. So a single ray passes through the raindrop. It suffers refraction and also internal reflection. It gets dispersed and it comes out. So violet is much above the observer. And one more ray we are taking. This is first ray and this is second ray. Second ray is also falling on the raindrop. So what is happening? It gets refraction. It gets refraction and internally reflected. Here it is internally reflected. Once it's internally reflected, here if dispersion is also occurring, so again we are getting 2 rays. After reflection, 2 rays, dispersion, 2 rays. here violet, and here red. So what is the situation happening here? The second ray is taken. Second ray also passes through a second raindrop, and it suffers refraction, total internal reflection, dispersion. Here we have to draw the dispersion. Here itself the dispersion is occurring. We have to draw that. Here we have drawn at the outer side. So here also two rays are emerging out. This is violet and red. See the situations. Rays from the violet ray from the first drop. This is the violet ray from the first drop. Is much above the observer. It is much above the observer. And also, see, this is second ray. The red ray, the red color, the red ray from the second drop is much below the observer. So, violet from the first and red from the second are much above and much below the water drop. So, its effects we are taking into account. So here, towards the observer, what rays are coming? Towards the observer, red and violet rays are coming out. So it is red, and it is violet. So this type of a rainbow is known as primary rainbow. Primary rainbow. In primary rainbow, red color is coming on top and violet color is coming down. All other rays are here. The violet is coming above the observer and red is coming below the observer. So the two rays, red and violet, are coming to the observer and we are obtaining a rainbow. That rainbow is primary rainbow. So for the primary rainbow, it's a three-step process. What are the three-step processes? Three steps are there. Three steps. First of all, a refraction is occurred. Then reflection is occurred. Internal reflection is occurred. Again, refraction is occurred. Or in another way, we can say that refraction is needed. Two refractions are needed. And one internal reflection is needed. Total process, refraction, dispersion. This is the particular thing that is happening in the case of primary rainbow. There is angular differences 42 and 40 between red and violet colors. Now, this is primary rainbow. Sometimes, in addition to primary rainbow, there can be a secondary rainbow also. So, what is this thing? What is the reason behind secondary rainbow? And what are the processes that are occurring in the case of secondary rainbow? Let us think. For that, we are taking two water drops. We are taking and a ray is incident on it. So here, first refraction is occurring and it reaches on other side of the drop. Firstly it gets internally reflected and it moves to other surface. Then one more time it gets internally reflected and it comes out. Okay, so what is happening? Two times. Here one time internally reflected, second time internally reflected. Two times the ray gets internally reflected. Two times internal reflections are occurring here. Now, so here this is red and this is violet. Now again we are taking another ray, another beam of light, another ray is passing and hitting on the second drop. It gets refracted and one time it gets internally reflected. One more time it gets internally reflected. This is the first internal reflection and this is the second internal reflection, and the rays are dispersed and coming out. Again, this is red and this is violet. Here an observer is situated. Here an observer is looking the things. So see the things happening here. The rays, the red ray is above the observer. Similarly, red ray from the first water drop. Red ray from the first water drop is coming above the observer. And similarly, violet ray from the second water drop is coming below the observer. So red from the first is coming above the observer, violet from the second is coming below the observer. So two rays are coming to the eyes of the observer, that is violet from the first and red from the second. So here and rainbow is occurring, a different rainbow is occurring with violet on the top, violet color on the top and a red color on the bottom. So this type of a rainbow is known as secondary rainbow. Secondary rainbow. So the differences are 50 and 53 degrees respectively. So this is the secondary rainbow. What are the processes that are occurring in the case of secondary rainbow? Or we can say that secondary rainbow is a four-step process. First refraction, internal reflection, second, internal reflection, third, again refraction. So it's a four-step process. And also it is seen that two times internal reflections are occurring. So after second internal reflection, the ray gets weaker. The reflected ray gets weaker. And the rainbow that we are occurring for a secondary rainbow is somewhat fainter, somewhat weaker, somewhat fade. It is not at all that much bright. This is occurring in the case of secondary rainbow. So we have discussed about rainbow. For a rainbow to occur, a drizzle is needed, a short rain is needed, and the rainbows are occurring opposite to the sun. If sun is at the eastern horizon, then rainbow is occurring at the western horizon. If sun is at the western horizon, sun is occurring at the eastern horizon. So this is happening in the case of rainbow. So lot of processes, lot of beautiful phenomena of physics are occurring in the case of rainbow. Inside water drops, some beautiful phenomena are occurring, like refraction, dispersion of light, total internal reflection, again refraction. So it's one of the most spectacular phenomena occurring on the skies. It's a beauty to watch, is it? Hope you understood it. Do write your comments. Write your comments in our comment box. We value your comments very much. Try to write. Thank you.